Good day, everyone. My name is Eddie Schwartz. I'm the Chief Security Officer of Block One, and I'm so pleased to be a part of this Hack in the Box Lockdown 002 virtual event and to be the second keynote speaker for this event. It's so exciting for me to be a part of this community again. I've known Dylan and the team for so long, and I'm so proud of the work that they do and so happy to just be part of this again. So let's get started. The name of my keynote is, Are We Far Enough to the Left Yet? DevSecOps, Chaos Security, and Not Being Left Behind. And let me tell you a little bit about what that means. First of all, when we talk about security in general, we've talked for decades, 3 decades in my case, about how can we build secure products? How can we get it right out of the box so that we're not doing all this work after the fact of chasing hackers or chasing vulnerabilities or chasing bugs that we've introduced into the system. And it's been difficult. We've tried lots and lots of things through the years. We're still trying things today. And there's been a lot of changes over the last few years that I think are really positive in nature. So what we're going to talk about today in this session is, first of all, how we used to do it. Because while some of you have been in security as long as I have, which is going on 30 years now, I guess, some of you are relatively new. So I want to give you a little bit of a history lesson and tell you how we got here and why some of the things you may be seeing in your organization, which may seem bizarre or too rigid or strange or whatever, just came from a history of dysfunction in some cases. We're going to talk a little bit about how we're still doing it in some cases, mostly in a lot of organizations. But talk a little bit about IT and engineering and what they're doing, and in some cases what they're doing without us, and that's not a good thing. And then I'm going to get into this idea of moving to the left and what that really means and what we could do better. And then we'll have some Q&A at the end. So let's get into the talk about the good old days and see what that looks like. So what really were the good old days? Well, I don't know how good they were, but for me, the good old days started with something which a lot of people know as the Rainbow series. The Rainbow series came out probably in the early 80s, I guess, early 1980s. Some of you are probably saying I wasn't even born then, but early 1980s, these set of books came out, and believe it or not, I still have them gathering dust on a shelf somewhere. But basically, these books had a lot of different sets of guidance for different things that you might be doing. For example, did you need to understand the security controls for a certain, in a certain situation? What would you do if a system needed to be top secret in nature? What did audit of systems look like? So there were lots of different colored books for different scenarios. And then there was an associated trusted product and evaluation program. We used to call it TPEP in the good old days. That really was about how were you going to verify that the systems that you sort of built or integrated and organized according to this Rainbow series really came out the way that you expected. So there was this trusted computer system evaluation criteria, which was the famous Orange Book that some of you may have heard of in your travels, or maybe it was a question on an exam somewhere you took along the way. The Orange Book was sort of the standard by which we all sort of tried to figure out, were we doing the right things? Did we create the right assurances, the right documentation, so on? And a lot of the test criteria came out of it. There were systems, sort of designators for systems. For example, you had the idea of C2 systems, B1 systems, A1, and those systems, depending upon the letter grade they received, could be used for, let's say confidential or secret or top secret. And obviously, if you were in the commercial sector, you were, like at a bank, you were thinking about, well, if I've got something that needed to be to that, to a high level of security, I might want to apply similar levels to those Orange Book levels in those days. It was a very labor-intensive approach, very documentation-oriented. It took forever in some cases. I mean, years to get something through a high assurance evaluation. Things evolved over time. Later, some of the early programs were government programs like NIAP, and eventually that led to what I'm sure many of you know as the Common Criteria. Common Criteria was interesting because it really moved security out of the realm of governments, like large governments doing security work, and it allowed for the first time for commercial labs to start working on standards, standards where things like protection profiles were created. Protection profile being essentially security requirements for certain classes of devices like firewalls and routers and so on. And then security targets. A security target would actually be the security properties of something. So for example, you might have a complex device that might have a number of protection profiles associated with it. Again, this was an improvement on TPEP, gave us a lot more sort of common standards to work towards, allowed for commercial labs to do these kinds of certification or accreditations and evaluations, but still suffered from a lot of problems. Now, for your information, for those of you that don't know Common Criteria, it actually led to a lot of really interesting things in terms of product security. And I've put on this slide, some of the details of ISO 15408 just as background for you. But, there were a number of different areas that actually have been through the years well developed. And some of the things that came out of NIAP and CC and so on were things like deeper introduction of threat modeling and security architecture, secure design, and a deeper notion of building security requirements. If you look at the following slide, what you see here is things that we learned through that process. Many of these things have endured today in various different models that are out there for product security. So for example, obviously the notion of risk analysis and threat modeling is pretty well adopted across any reasonable model of product security. Security requirements, security architecture, these are things that a lot of organizations try to get to. I think the notion of code analysis probably has not been as broadly adopted as we would like to see, and different models have different levels of specification, and we'll talk about that more later. Secure configuration management, meaning the idea that you don't just write code, but ultimately, you've got to both secure the code itself and then build it on infrastructure and other SDLC artifacts. So how do you do that? Of course, you have to have a physical environment in which systems operate. So the notions that were created around, well, what kinds of people do we want touching these systems? Do they have to have security clearances? Does it have to be in a secure data center? Again, many of you that have done different types of general security work are probably familiar with these notions, and the notions like vulnerability management, where we're going to do black box, white box testing, and also look for inherited vulnerabilities, for example, received from downstream third-party libraries like open source libraries, where you might write a piece of code with that library at one point, and then later you find out that it has been updated in 2 years and there's been scores of vulnerabilities that were brought into your code. Couple of last pieces I think I want to highlight, just the last one here: security training. You might say, well, we do security training, but actually security training for developers, where you're trying to train developers to build secure code. So some of you know things like OWASP and things of that sort, but really is, how do you make coders better coders from a security perspective? Many of these concepts came out of the work of the 90s of Common Criteria, and really became part of what many organizations through one piece or another do as ProdSec. So I think, in summary for this section, there's a good and a bad of the old ways. The good is that through the different frameworks and work that was done through the Rainbow series, Common Criteria, Microsoft SDLC, some of the other frameworks of that time period, we developed a way of understanding what we plan to build, creating security architectures, creating requirements and associated controls, and also various types of testing regimes that could prove useful against the requirements that were implemented. There wasn't necessarily a standard approach to that, not that there needs to be, but there are various approaches, and depending upon which regime you used, it could be anything from a paper exercise to very, very deep testing. The bad part of all of this, and there were a number of things here, is threat modeling was typically not dynamic. You did a threat model, you built a system, and then, if the system changed, you really didn't revisit that frequently, at least in some of the approaches that we're taking. Certain approaches took forever to do. TPEP, as I mentioned, took years. In some cases, I recall in my career, we were doing common criteria evaluations where, we'd be a year or more into the evaluation, and the system had been updated 2 or 3 times beyond the original scope of the evaluation. So the evaluation was already overtaken by events. And that's not a good way to do security, and this ties to the last point, which is threats are constantly evolving. So the threats that you begin to look at in a long-term evaluation, you're way into new threats by the time you finish it. And it's not very useful at that point. And technology change is continuous, whether it's changes to the way cloud is delivered, the way infrastructure is delivered, containers. I mean, I could go on forever with technology change. And so that approach is just not practical for the volatility of both business and technology environments, and what we will need to do for something like DevOps or DevSecOps going forward. So security has been taking lessons like that away from all of this for more than a couple of decades now. But unfortunately, as the next slide from our friend SpongeBob indicates, we still come back to this notion of, well, yeah, but can we play that song again? Can we do that again, which we already know wasn't working out very well for us? And unfortunately, we continue to see that same thing occur over and over again in many security teams, where we know that something really isn't working out, but whether it's because of the training organizations, continuing to teach things in an old way, whether it's because we still have this notion of security generalists, or because our industry as a whole hasn't really understood that security can't exist as a thing unto itself the way it has for so long. We continue to revisit these old approaches. So does the old approach still work? Well, no, it's not working anymore, and it needs to change. If you look across some of the aspects of what we do in security, product security is hard. It's hard. First of all, it involves code. And, most of us in security, probably not at this event, but, most of us in general, we weren't trained for that. If you look across the workforce in security, you find a lot of generalists, a lot of people from networking, people who came from the audit field, people who came from fields who didn't come up through some sort of field where they were deep in code as the early part of their career. And it doesn't necessarily have to be C++ or something like that. I mean, really, though, had very little exposure to coding or even worked with coders in any way at all. And then the people who work in security who used to be coders or who just came up as coders in security don't necessarily want to sit in engineering teams as their day job. So, we've got a gap we need to look at here, and I'll talk about that a little bit more in a minute. It's not a pen test, right? I mean, that's not the problem we're trying to solve here. We can't just implement a list of controls and hand it to the engineering team and say, do this. That was the problem with common criteria, and it's still the problem with that, because there isn't a protection profile or a security target for a lot of the things we're building today. And again, you know, those checklists only go so far. It's definitely not a compliance checklist. And most importantly, we can't do this in a silo. A lot of times security teams still exist in a room over there where then they try to basically hand a development team or an engineering team a bunch of standards. They're just not going to do what we say just because we're security. I mean, maybe some will, I don't know, but they're not just going to do it because we say so, because they're more aligned with the business than we are, if you think about it. I mean, they're building code or they're building systems because they were asked to by the business. The business may or may not have asked for security. I mean, I hope they did, but they definitely asked for the system to be built because usually it's associated with revenue or customer service or some direct correlation to a business requirement or, you know, some government mandate or something that, you know, is trying to get done. So, you know, it's definitely something that we need to overcome. So sometimes when I speak at events, people say to me, well, you know, how do I speak the language of business, or how do I get IT guys to do things? Well, one of the ways to do it is go and ask them what they're doing, because you know it's kind of funny when you go find out what they're doing over there in IT. You know, I mean, in a lot of cases, you know, for example, you know, we're off doing things with PMP and waterfall and, you know, all these methodologies to track things. And, you know, they're doing agile and scrum. Well, again, you know, you might think it's a difference in methodology, but it's a big difference in methodology. You know, for example, if they're working off a product backlog and you don't know what that is, that's a problem. They're doing 2-week sprints where every 2 weeks they're continuously or incrementally improving the system. They're doing peer reviews already. They're retrospectively looking at their work. They're constantly improving what they're working on. They're doing this every 2 weeks. And if you know, if you're being fair with yourself, you know, if you're already doing DevSecOps and you can turn the Zoom off or whatever you're listening to now. But I mean, if 2 weeks seems like a short amount of time for you to do security works, you know, but that's what you need to do today. You know, in security, I mean, we're used to waiting for a pen test to finish, writing a report, send the report out, wait for somebody to fix something, you know, send a list of Qualys vulnerabilities to IT, hope they respond to us, Kubernetes security configuration. What's that? You know, I mean, this is the way we run our lives in security. Meanwhile, another 4 2-week sprints went by and you're still trying to figure out what they're doing in IT, you know? So we really have to change the way we're doing things. Otherwise, you know, we're going to be left behind, as I mentioned in the title of my presentation. Well, there's a good part. And the good part is that IT actually wants help. I mean, engineering teams want help because they have to do security. They have to do security, okay? And if you think about it, engineering wants help for a really important reason, and that is that security requirements are important to them. They're important to them just at a very high level. They don't want to lose money. They don't want some security or privacy related mess on their hands. They don't want the company reputation to suffer. There's a million reasons. You don't even have to get into the fear, uncertainty, and doubt discussion to get the point across. They will say that on their own. Most engineering teams are at the point where they get it. But what they don't want in response to it is a security framework or a checklist of the OWASP top 10. That's not really going to be helpful in a world of product backlogs and sprint planning and things of that sort. So engineering is going to move at a certain speed. You know, assuming you have an engineering team that's using Agile as a most basic level, again, it's going to be a 2 or 4 week sprint, and it's going to follow this basic approach that you see, you know, on the screen here with Agile. But they want a partner, and they want us to fit in to the work cadence that they have. So we've got to figure out how to do that, right? So let's start by thinking about what are some of the key differences between what they're doing in IT or engineering and what we're typically doing in security. Again, some of you may be way past this, and that's cool. And if so, help bring everybody else along in the industry, because that's really important. But some of the key differences, for example, are in engineering, at least in Agile anyway, or DevOps, the work tends to be iterative in nature, okay? It encourages interaction and openness and transparency, okay? Everybody knows what everyone else is doing. It promotes frequent adjustments. So this worked, this didn't work, show your work, show how it's going, let's adjust a little bit, let's refine, that's a word, let's refinement, refine the backlog, right? You know, it's a constant iterating, improving process. It's meant to deliver working products quickly. Okay, speed matters here. It's not, wait a minute, we're not ready yet. Oh my gosh, that's the worst thing you can do, right? It's about get the beta out, get the MVP out. And there's comfort with uncertainty. There's comfort with uncertainty. Historically, security has been point in time related, okay? We did the pen test. Okay, well, what about tomorrow's pen test? There was a new release done. Well, do you need to do another one? Well, when do you need to do another one? That's a tough thing that to even think that way is probably defeating what you see on the left. Is top down dictated, meaning here are the policies. You know, again, they could change. So how do you deal with that? Probably not good. Security tends to be secretive and siloed at times. Well, we can't tell you what they're doing. Why not? We could all benefit from each other if we all shared information transparently. Okay, maybe there's some things that do need to be secretive, right? But the more the teams learn from each other and the more they collaborate, the better. Certainly, we dislike frequent changes historically, and especially we like pivots. Oh, we're not going to use this approach to multi-factor authentication. We're going to use this one, which we just found out about yesterday. Wow, what? You know, but it's okay. It's okay. It's better. It's better. Well, maybe it's not better for us, but it's better for the end users, and it's probably more secure. It's too bad that you just worked on the other one. This one's better, you know. We struggle with short timelines, that's for sure. But again, we have to move at the speed of engineering, and certainly uncertainty is a bit problematic for us. So, you know, I think of the tortoise and the hare story. I don't like that story because I think that we need to be both or neither as we do this work. So I think one of the things that I did recently, I swore I was never going to do another certification. And I went off and I got my certified Scrum Master, right? And I was like, well, why, right? Especially at this point in my career. The reason why I did it was because even though I'd been working in Agile for a long time and working with dev teams for a long time, I really wanted to see, you know, I wanted to hear it from inside people that were working every day in Scrum teams and understand what it felt like to be a part of the team in that way. And I would strongly recommend it. You know, it's an open book test, 2 days. It's really easy to do. It really gives you a perspective on the fact that you have no natural home whatsoever on the development team. In other words, one of the things I did during this class was I asked people, I said, where does security fit in all of this? And I mean, literally they looked at me like I was nuts or something. There was no natural answer to the question, because the notion, first of all, of roles is sort of foreign to the concept of Scrum or Scrum teams. It's sort of an egalitarian system, and it's really more about what is in the product backlog and what needs to be done. And so the idea that there's some security team out there somewhere that's going to interfere with this life cycle that you see on the screen is just like a completely weird idea for me to even ask about, as opposed to somehow making security a part of it, where it was organically a part of it in some way, if that makes sense, versus having it, I got to build a security process, into this that's a unique process in some way. So if you think about it, right, a security feature like multi-factor authentication has to be part of the product backlog organically. That's not to say that a security SME can't consult to the requirements definition and things like that, but it's part of the backlog. So if security requirements aren't part of the architecture of the system, the design of the system, they'll never get written into user stories at all. And then you're back to the stuff that we don't want to do, which is security bugs later and testing later that proves all of the wrong stuff. So I would encourage you all to understand this life cycle, because it's an important starting point to understand how you can build DevSecOps in your organization. I also started to understand the idea of where chaos engineering fits in to security engineering and DevSecOps. And no, it's not the old chaos program. It's something else, right? So chaos engineering is the idea that essentially you take the current state of a system and then try to introduce a bunch of failure states into it and observe those failure states to find a faster path to see what's wrong with it. So a lot of it is used in engineering to essentially look at the resilience of the system or breakpoints of the system as an alternative to like quality assurance testing or other testing like that. And there's an entire security domain that's sprung up around this as well. Is sort of a short circuit for sort of long-term testing that then becomes overtaken by events. Okay, anyway, so you have to ask yourself at this point, do you sort of live in this incremental trying to change, from your old life in security to some new life, or do you basically just go all in and try to adopt what is happening in the engineering teams and sort of move in that direction? And I think what I've figured out is that there's no way to do it the old way anymore. So if you think about DevSecOps, the first question is, well, what is it? The easiest way to think about it is breaking down the silos that exist between security and everything that looks like engineering. So, for example, in engineering organizations historically, there was sort of agile, right, which would be like the dev teams, and then operations like infrastructure operations or cloud operations or data center operations, right? True DevOps represents the integration of those, and the more they're integrated, the better. Similarly, in security, we've seen sort of product security teams and then security operations teams that sometimes you could lump vulnerability management or GRC or whatever into those teams. So depending upon your company, some hybrid of those approaches work, but the idea is to, first of all, put as much together as you can where, engineering teams of different capabilities and security teams of different capabilities are all sort of living together and working together within their pieces of the life cycle. So full integration is sort of the common denominator. And I'll talk about what that looks like now. In this diagram, which I borrowed from Gartner, but it's out there in other places as well. Just the diagram is borrowed from them. The rest is stuff that from various sources. The activities here are illustrative of, in the diagram, are illustrative on the left of typical activities you'd see in the dev side of DevOps, and on the right, some of them are operational in nature. And the entire picture sort of represents some of the pieces of DevSecOps. And I'm going to focus a lot on the left because the title of the presentation is moving it to the left, the idea being that the best bang for the buck comes from the left side of this diagram, which is security by design. But at the end, I'm also going to talk a little bit about the right side, which was traditionally in the domain of security operations and so on. So when you think about this diagram, there's not really a starting point, again, because it's again a continuous life cycle of continuous improvement, continuous delivery. But I guess if you want to start somewhere, what we can start with is the idea of plan and create, because if you have a new system and you're starting off, right, the first part to start would be in the plan section. So when you think about plan and create in DevSecOps, for a new product or service, the initial product definition and design would be created by a conglomeration of stakeholders, potentially users, engineering, and different SMEs, including security. It's critical that security not be a, quote, consultant to the project that's just, hey, got any security requirements here? But it is really part of the team. And not, again, back to this whole notion of, are you in or out of the diagram? I mean, security is part of the development and engineering team from day one till the end of time on this. They don't live in another office. They wear the same color shirt. So they're part of the design of the product and the initial, product requirements. They're part of the architecture, and those are living, documents, if you will, for lack of a better term. The plan and create phases ultimately, past the beginning piece, become 2 or 4 week sprints, and that's iterated in terms of product increments, which are what's delivered by the development team every 2 or 4 weeks, or however long your sprints are. And in every one of those 2 or 4 week sprints, there are security things occurring along with all the other activities that are occurring. And they're just part and parcel of what the team does. It's critical that the product security team, if you will, have members that are part of the Scrum team with the right technical skills, meaning they're likely going to be coders in most cases, or they may in some cases have infrastructure or skills, and be available for sprint cycle activities. Some of the things that come out, for example, here, obviously there's an initial threat model, but then there needs to be incremental threat modeling that would occur in subsequent iterations. Security architecture, including detailed data flow diagrams. Everyone should always know how things interact with each other, which programs are allowed to access what, that users are allowed to access what. That's critical to getting this stuff right. And again, that can be implemented as code if you're using the right tools. Security themes and objectives. I mean, security themes would be things like don't steal the money, or don't steal account information, or stuff like that. And that translates to security requirements that developers can easily follow when the product owners, when it's story time and stories are related. It's easy to think about implementing certain capabilities in a system when you sort of know that, well, you've got these security principles, security themes and objectives that are guiding you when you're building a certain aspect of the system, or when you've got an iterative threat model that's helping you do that. Threat model, let me say a couple things about tools here, sorry. Security teams should be using the same tools as the engineering team. So everything is in Jira or Confluence, for example, or similar tools. So where the product owners and the development team are managing their work, security team is in the same exact place, using the same exact sprint cycles, posting issues the same way. If security has their own sprints, they're modeling them too, and using the same burn down charts and everything else. Threat modeling, which is a security specific activity, it is possible to obtain commercial tools so that everyone on the team can share, and not just security team, but the whole team can share in that. And there are open source threat modeling tools that actually implement threat models as code. In the verify phase, what we're talking about are where security tools and techniques are applied to the work performed in each sprint by the development teams. So for example, it may be necessary to apply the security SME that are part of the team to help use the security tools. This could be things like dynamic analysis tools, static analysis tools, source composition analysis tools that are looking for like inherited vulnerabilities that come from open source libraries or things of that sort. There may be situations where you want to have peer review done with a member of your team that might be a coder that can look for potential security issues within the code. Maybe in some cases you want outside experts to help with that. Everything you do should still, again, be placed in the same Jira buckets as everything else that's a part of the product backlog or issues backlog that's used as part of the sprint cycles. And again, in this part also, keep in mind that the development teams should grow and mature as part of this. Part of the Scrum objectives, of course, are to improve what we're doing all the time. The development team should grow in the use of their tools, and it's on the security team to help them grow. I'll just talk briefly about the production and release phases. If you're in a DevOps shop, you probably hear the term CI/CD a lot. CI could be continuous improvement, continuous integration. Obviously, CD is continuous delivery. But it's this idea that you're constantly building code and releasing it. And this could be every week, every day, every hour. So imagine old school security processes trying to keep up with that release cycle. It's very difficult. And so the idea of automation and removing as many manual processes as possible is critical for this part of the DevSecOps work. And really what you have to do is think about what tools and what checkpoints might need to exist in the CI/CD pipeline where they could be automated, but also where if there is an error condition, only when certain errors occur might there be a stop issue or some issue that would require you to slow down the pipeline in some specific way. And it should be highly unusual in nature when you get to this point. Similar to other aspects of product security, the pre-production and release cycle, particularly in the pipeline, requires a dedicated focus and deep technical expertise, because a lot of what's done on the automation team and the development team is highly complex and is potentially error prone in nature if it's not done right. And we've talked a lot about moving to the left and the benefits of doing that, because again, you can solve a lot of the problems that you would typically find, in bugs and, sort of code related problems, inherited vulnerabilities, security problems with the pipeline, For example, I forgot to mention in my previous slide, things that you would do like, cryptographically signing code, when it gets into the container and so on and so forth. But there's a lot that happens on the right side of DevOps as well, and DevSecOps. And it's important to note that all of this stuff is really critical. And also where, for example, the SOC team can work closely with your infrastructure operations or cloud operations team. And a lot of this work, is important to bring together in terms of planning, designing, and operating. So some general right side considerations. If you're in a DevOps shop and you're using containers, for example, it's highly likely that your infrastructure is deployed as code. That's really good, actually, because as things move through the pipeline, including infrastructure, like containers, for example, you can deploy all kinds of fun things as code if you're a security person. Secure configurations, like compliance-related things like audit capabilities, vulnerability management agents, security monitoring agents. I could keep going, but the point is that it's good for security that that's the case, and you should take advantage of that. Again, I mentioned before, and I'll mention again, it's important that the security team be part of that capability to automate and include security capabilities in the pipeline, and then operate those capabilities when they come through the pipeline. But one thing that you should understand is your needs in security operations may or may not have been considered by the product managers and product owners upstream. In other words, a lot of what we talked about earlier in the presentation was integrating security into the building of the product successfully. The product owners may not have in their list of requirements, build audit functions into security operations, or build Kubernetes orchestration, all these things that you might see as what some people would call internal product capabilities or internal facing product capabilities. So similar to other places where you're going to integrate in DevSecOps, for the stuff on the right, you have to be able to make a case to the product owner and product managers that these are additional product backlog items that need to be included in the product, because the dev team will need to build them for you, and the automation team will need to automate them for you within some of the sprint cycles, and your requirements here will be competing like any other requirements. Now, depending upon your organization, maybe you build your own development team that again works with the product owners and so on, but you build your own resources and development team that can execute these sprints for you. And there's nothing wrong with that, and that's a really great thing if you can put that together and execute it on your own. So, what I've tried to do during this presentation is provide you some insight into how, the history of this looks, and how a lot of great things emerged over a couple of decades in terms of building secure products and so on, and some of the weaknesses of that. I've talked to you a little bit about DevSecOps and why we need to adapt our security processes to the way engineering teams are building code and integrating systems today. And I've talked about some of the different components of it. It's difficult to do this, and it's resource intensive, but certainly, given some of the information I've provided today, I hope you can take some pieces of it and at least start implementing some of the components. I mean, if you want to start somewhere, I would definitely start on the left side, and at least start building some capabilities within your relationship with the engineering teams, because it really does help if you can build the code securely, and you can also develop that really, really tight relationship with the business and the product owners. Working together really is the key to all of this. And I think the less that security is called out as sort of an independent function where people have to check with them to see, is something okay? And the more we're seen as a part of the team that's building the future of a company or building the success of a government agency or, wherever it is you work, I think that's where we'll be successful ultimately. So these are my prepared comments for today. I thank you for your time, and hopefully we have some time for questions. Thank you very much.
We've got a few questions, quite a few actually.
Yeah, I saw them.
The first one is, what can an organization do to attract the right kind of talent from the start? A lot of fresh grads are unhireable, undeployable, and require intense retraining.
So with regard to that question, I think part of the challenge with that question is what are you really hiring for? Part of the point of my presentation was really to bring out to you that if you're working on the left side of DevSecOps, the goal that you have is to integrate security into what the developers are doing. So I think part of it really is to focus on, is the team hiring people that have a computer science background or good coders and so on? If you're needing people on the security team to work in product security, are you hiring people with a code background or people that have done coding before? And then you are going to have to build up security capabilities within that group. But I think the key is to really look at what you're trying to do in the framework that I mentioned of Scrum or Agile. And the key things are, you're part of that Scrum team, which really is focused on engineering, right? So that's really where you need to start there. But I agree with the questioner that it is hard. You don't necessarily get what you want out of somebody you hire out of a degree program. And you have to assume that there's going to be a training program, as I mentioned, that's going to include both things that are engineering related and things that are security related.
Fantastic. Hope that answered your question, Anonymous. Next, we have a question from Ali Mutu Ahok. I agree your opinion on code analysis being the least adopted security strategy. Our security team is very reluctant to go beyond dynamic analysis, which is burp. Is it mandatory to check the code analysis box, and what are we missing for not doing?
Yeah, so again, part of what is important in the framework that I presented is that a lot of the work has to be done within the 2-week sprint, okay? Part of the point of the presentation was, if a security team is off doing all this analysis, you're too late, probably anyway. So the trick is to build a code analysis framework that really runs at the speed of dev. If that makes sense, right? So if you think about it, right, let's talk about some of the things that you mentioned, okay? You can set up within a developer's work framework, for example, source composition analysis. There are tools out there that will do source composition analysis on a continuous basis. So when a developer implements a library, there's an analysis done as to, can I use this library? Does this library, is it up to date? Are there known vulnerabilities? Oh, I need to update, and so on and so forth. And you also can implement SCA as part of the automated process in the CI/CD pipeline. So again, that's not done by the security team. The security team consults on implementing that tool and helps to implement it and helps with the training of the dev team. But the security team is not doing that work. Similarly, for static code analysis or SAS type of tools, the idea would be to provide some of that as far left as you can. So it's part of the process that the developers are doing, but certainly you want to automate SAST and DAST to the degree possible, and not have that be a manual process that a security person has to come and run a tool and submit a report. And we're going to fail if that's the model we're using. Now, when you think about other types of code review, for example, let's say we wanted to do large scale fuzzing, which is very, very valuable as a code analysis technique. There you are really looking at the potential of setting up, different types of fuzzing clusters and approaches there, where it could be run, by the security team on the product security. And you could have different priorities for putting code through that and discovering vulnerabilities on an ongoing basis. And then obviously, filing them as issues and fixing them as bugs, much the way that you would treat a bug that would be discovered, through a bug bounty program or through, other types of regression programs where you would find them later. So, obviously fuzzing is a very valuable tool, but it's a tool that requires time. And so those are bugs that would be dealt with later, in sort of a, post facto way. Manual code review should be used where you really are trying to focus on what are the most sensitive areas. And, again, and where you do that peer review as part of the sprint, great. But if it's something that you have to do, as part of a major release or something like that, obviously that's probably the most old school aspect of it. But, in some cases for really sensitive components, it's something that, again, you would potentially do outside of the sprint framework and file bugs or other findings later. I hope that makes sense.
I'm sure it does. That's a very thorough explanation. The next one by Anonymous. Shouldn't we be teaching security fundamentals and outside the box thinking at a much younger age if we hope to create better security professionals? Isn't it harder to shape a mind once it's already been entrenched in an old broken way of thinking?
Yes. I think the question is what security fundamentals we're teaching, right? Because if we're teaching, according to, the way I, was brought up, well, actually I was brought up before we even had certifications and all of this, so I don't really count. But, certainly the last couple of decades, as a lot of the curriculum is based on CISSP or, these types of things, which really, tried to put security in a lot of different boxes. But again, if you've done security for n number of years, you know that a lot of people consider it to be an uphill battle or a battle that, where you're constantly fighting different forces of different kinds. And part of the thing that I've seen in successful teams is the deeper the integration with engineering and the closer we are to what the business is trying to do, the more success we have. So I think the security fundamentals question really is about, are the fundamentals really the right ones? And are they associated with what's really going on in your organization? Or are they some doctrine that, was in the beginning of my presentation that was created in the 80s or 90s that, there were some very good things that we learned how to do, but that really aren't how, teams are building code right now. Or, infrastructure is being delivered as code now. We're not doing it the way we used to do it, where you stick a thing in the rack and, it's just not, it's not the same anymore. So we need to change just like technology is changing.
Fair point. On to the next. How do you think the security industry is going to evolve from a defensive standpoint, keeping in mind the new normal, which means more workforce working from home remotely?
I think there's a couple of questions here. I think the last one treats the work from home piece a little bit too. I'm actually a big advocate of work from home for a lot of things. And certainly this whole situation globally has made us rethink a lot of work from home scenarios. Certainly we've seen that in a well-managed environment, it's you can keep productivity at a good level. If you plan for a remote workforce, it's fairly easy to manage access controls properly and things of that sort. But I also still go back to what I said in the presentation, which is if you use something like Scrum or Agile as an approach to the way you're doing something like product security or even some of your project management, there are certain notions there that make it easier to manage a remote workforce. For example, daily stand-ups. I'll give you an example. There's some security issue that you've discovered that requires you to work with IT, security, GRC, some other people, some organization. You create a 2-week sprint to fix the problem. If you're doing it the right way and you're following Scrum, for example, you're going to have a very, very specific way of doing things. You're going to have sprint planning. You're going to have the daily stand-ups. You're going to have peer review of the work. You're going to document what you're doing, in a system like Jira, something like that. There's a very specific way, and there's going to be a lot of transparency, a lot of openness. And at the end, you're going to have a review. We're going to say, how did we do? And I think traditionally, again, we don't really work at that cadence and that transparency, in that advocate of work from home. I think we can do our jobs in security. And I also think if you take some of the things that engineering has been doing for a long time and apply them to our work in a work from home scenario, we can be successful. And to the point of the last question, I also think we can do it, by managing access controls and confidential data the right way too.
Do you just want to expand on how do you think they can use access controls to maintain and keep track of confidential data? Has it been successful in your experience?
That's a whole presentation unto itself. So,
okay, sure.
I guess it depends on what access controls, honestly.
Right, fair enough. Okay, and we'll go on to the last question then. What would be your top 3 not-to-do lists for running a security team in a tech startup?
I tend to be more of a to-do versus not-to-do kind of guy because I'm an optimist. So, I guess my big to-do, just based on this presentation, really is to think about doing DevSecOps as a way of life in security. I'm a firm believer that if we don't do this and we don't change the way we're doing security and delivering security results, we are going to be left behind. It just doesn't work to have this silo, where we're consulted on things and go see the wizard, and see what, security has to say about things. We really have to be better integrated, and be able to work more closely with the teams. And DevSecOps provides us the way to do it. So that would be one thing. I think, integrating with the business and with the development teams is critical, to that. So that would be the second thing is really to part of the other teams. And that means giving up the organization a little bit. People, ask me sometimes in my job, well, your organization, what is your organization? I try to de-emphasize security as an organization and more emphasize how my team members really are part of engineering or part of other teams that they need to be a part of based on what we're doing at any given time. I guess if I had one not to do list, it would be the opposite of what I just said, which would be, don't operate in a silo. That's the worst thing you can do, because, you're setting yourself up for isolation. And you can't get much done if you're working alone and setting yourself apart from everyone else. So those are my 3 answers for that.
Very good. I think that's all the questions we've had. Thank you so much for taking the time, Eddie, to take the questions live. I know it's quite late in DC.
It's great. I'm always pleased to be a part of the Hack in the Box community. Thanks to all of you that work on the conference and volunteer time, and thanks to Dylan and everybody, and thanks for all of you that attended the event and attended my presentation. I really appreciate it.
Nice. Thanks once again.